Good afternoon, everyone. My name is Isabella Namganza, and today I'll be discussing two important questions in artificial intelligence. That is, can computers think, and will they ever think? In relation to my restaurant management project. Yes, so let's go forward. The topic of machines thinking has fascinated scientists for decades. In this presentation, I will share insights on what thinking really means, what AI can currently do, and whether future advancements could really make thinking machines a reality. So, what does thinking really mean? Thinking for humans is more than just processing data. It involves reasoning, problem solving, decision making, emotions, and so on and so forth. Whereas computers only follow algorithms and manipulate symbols, they don't understand what to do. You basically program them to do what? You basically program them to do something. They can't decide on their own, and so forth. So if thinking really means this, thinking comes with reasoning, with emotions, which computers do not have, then I don't think computers really think, because computers don't have emotions. Yes, they can fake it, like a machine in a restaurant. You could you could give it you could uh, you could tell the machine or the robot that the food was really bad. It would say, "My bad," or "I'm really sorry for that." It is just surface level, but I don't think it really means what it is saying. It was just programmed to sense emotions in people, but them themselves as machines, they cannot feel the emotions and empathy and everything. So I don't think I don't think computers really think. But the second question is, could they ever make a computer that thinks? Let's see. Thinking basically requires more than logic. So Howard Gardner uh, listed eight types of intelligence. That is the linguistic, logical, mathematical intelligence, spatial intelligence, body kinetics, didactic intelligence, musical intelligence, interpersonal intelligence, and naturalistic intelligence. Computers excel in logical and sometimes linguistic, according to the programs given to them, if they can, be able to speak different language. Computers cannot exercise the other six, the body, interpersonal, all that and everything. Another Other forms of intelligence, we have emotional intelligence, which requires recognizing, understanding, and managing emotions. As I had said on slide 3, I think. Yes, computers do not have this emotional intelligence. They cannot recognize, they cannot manage their own emotions. They don't have emotions. They, as I said before, they are just programmed on what to say, on what to do. So yet humans can do what, can decide on what to do and what to say on their own without being programmed. So computers don't have emotional intelligence. For example, in a restaurant, as I had said, in case there are there is a customer who's upset with the food that has been served. Yes, computers will sense it in the tone when the customer is like, "I don't like the food that has been served." The computer can sense it and is like, "Oh, we are sorry about that." But that is on surface level. You get, it's not from deep. It's not an emotion released. They really don't care actually if if you if the food was served well or not well. So they just mimic empathy, but they lack the real feeling. So computers do not have that emotional intelligence. So Alan Turing in 1950 carried out an experiment to 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 verify if computers really think or understand. So the question was like, can computers think? This experiment included a judge, that is a human interrogator, a human respondent, and a machine. The judge was texting both the both the human respondent and the machine. And if the text was the judge was texting them questions, and if the judge wouldn't differentiate the reply between the human respondent and the machine to say that this one comes from the human respondent, this one comes from the machine, then the machine must have passed then the machine passed the tests, passed the test showing intelligence. But passing this test does not mean that the machine understood. It just followed programs that were given to it. It just imitated. So the question still that the debate wasn't over. Uh, if machines really think, the question that was formed is mimicking thinking the same as real thinking. I personally, I don't think it is, because I don't think machines think. As for the Chinese test, a person was locked in a room. They weren't understanding English, but they had a real book that tells them how to respond to the Chinese characters. Chinese speakers outside the room passed in the Chinese questions. Yes, the person using the real book would pick the right symbols and send them back. To the outsiders, it looks like the person was understanding Chinese, but inside the person doesn't understand a single word. That is how computers are like person in the room. They follow algorithm and to manipulate symbols. They appear intelligent, but they don't have real understanding or consciousness. Um, so theories of mind and limits. In psychology, theory of mind is the ability to understand that others have their own thoughts, feelings, and intentions. For example, if your friend is sad, you can guess their behavior. It's about empathy, perceptiveness, and predicting mental stress. Theory of mind in AI. Current AI like ChatGPT, Siri, Alexa, etc., they don't have real theory of mind. They don't understand emotions or intentions. They just process input and output. True theory of mind in AI would be maybe recognizing human feelings. Yes, yes. Computers can recognize human feelings. They can recognize that yes, you are sad, predict human behavior. They can know what humans are doing or about to do, adapt responses based on emotional contexts. Uh, they can also do that, and etc. So for classical AI and connectionist AI, classical AI programs follow explicit instructions written by humans, if then rules, decision trees, logic statements. Then connectionist AI, knowledge is encoded in patterns of connections and weights rather than explicit rules. Here, learning occurs via training and experience. Weak AI and strong AI. Basically, weak AI is designed to perform specific tasks, that is like chat, Siri, Alexa, Google Translate. Whereas strong AI, what they think strong AI, will- what they think the scientists think that strong AI is going to do, can think, reason, and understand like humans across any domain. It would have consciousness, self-awareness, and genuine understanding. Basically, it would be better than the weak AI. Restaurant AI today is efficient but not conscious. Yes, the robots are there, they do the serving, but they cannot reach their customers' expectations like how a human being would do. So superhuman intelligence, refers to intelligence that surpasses the best human minds in virtually in all fields, including problem solving, creativity, social skills, even scientific reasoning. It is often discussed in the context of artificial intelligence. That is in relation to strong. It is in relation to strong AI. In short, uh, superhuman intelligence, that is AI smarter than the smartest humans at everything. It is the next big step beyond strong AI. Currently, it's theoretical, but it's what scientists basically right now are working on. So, with all that said, for our conclusion, if machines could think, society would face tough questions like would they have rights? Because them thinking basically they would be like humans now. So they have their rights. How would this affect jobs and relationships? So responsible AI development will face those questions. In summary, today's computers cannot truly think. Though future technology may change this, we are not very sure. But achieving consciousness remains a massive challenge to the scientists. They will really gain the consciousness, the empathy, and multi intelligence. Yes, thank you for listening.